So you have a problem. They are asking you to identify same. What is your nodal displacement? What is the element stress? And also what is the support reactions? This is the overall data they are asking. You can convert it into three elements. Okay. So because you have a force here, because of this force, you have to split it as this one as a single element. This another element. There is a difference in cross section area. So another element. So one, two, three. Okay. So let me proceed. So we have three elements here. So this is my line. Okay. So first element, something like this. So element nodal point 1 and nodal point 2. Second element, nodal point 3. Third element, nodal point 4. So element number 1, element number 2, and element number 3. So if I consider what are the data you have here U1, U2, of course F1, that is also possible, right? So U3 and U4, right? And if I consider what is the area, so you can able to see that this one we call it as A1 L1. So AL or okay, A1 L1, and I think Young smallest is common. So A1 L1 and E. So this is also same. These two is same, right? Because only because of the load we are dividing here. This one is different. A2 is different. L2 is different. E. This is the other part. Okay, right. So this part is over. So I have identified what is your element. I have find out what is the locations with respect to that. Second step is I have to identify global stiffness matrix. Right? What is my global stiffness matrix for this particular problem? The size of the global stiffness matrix is 4. Right? So you can able to see that you have 4 nodes and each node is having 1 degrees of freedom. So size of global stiffness matrix is 4 cross 4 matrix. Okay, that is over. Now the next step is I have to identify what is the element stiffness matrix for each element one by one. So let me go for first element 1. So element 1. For this element, okay, so I will write as K12. K12 is A1 E1 by L1 1 minus 1 minus 1 1. This is my stiffness matrix. Okay, so which I can write as A1. So A1 is 250. E1 is Young's smallest, which is 200 gigapascal. I can convert it. So because everything is in mm, so which means 200 into 10 power 3 Newton per ohm square. Okay, which is 2 into 10 power 5. So 2 into 10 power 5 divided by L1. So for this element alone, the length is 150. And it is 1 minus 1 minus 1 1. Right? What is the value for this? 3.33 into 10 power 5.
5, yes, sir.
Right? So okay, so we're getting 3.33 into 10 power 5, limit 1 minus 1 minus 1 1. So this one I'm going to write as, so I'm going to answer 1 into 10 power 5 outside. I'm remaining bring it inside. So which means I will get K12 will be equal to 1 into 10 power 5 of 3.33 minus 3.33 minus 3.33 and 3.33. This is my value, right? This is my part. Any doubt up to this? So this is for element 1. Right. Next, I will go for element 2. Element 2. So if you look here, your length of element 1 and 2 is same. Area is same. Young's smallest is also same. There is no difference between element 1 and element 2. right? Same formula I'm going to apply. A1 E1 by L1, 1 minus 1 minus. So in that case, surely I'll get the same value, right? So what I can do, I'll rewrite it. That's it. So I'll just rewrite this particular value. Same thing I'm going to get for element 2 also. No change, right? Only thing what I have to do is I have to change this, right? This address should be 2, 3. Connecting element 2 and so nodal point 2 and nodal point 3. Okay, right. So next we'll go for element 3, right? So when you go for element 3, look here. So this element is a full element. Of course, it considers A2 E2 by L2, right? So element 3. So it is connecting 3 and 4, right? Which is equal to A2 L E2 E, because your Young's model is the same, divided by L2 under the limit. So it is minus 1, 1 minus 1 minus 1, 1, right? So which is A2. So your area for this is 400. So 400 into 2 into 10 power 5 divided by L2. What is your L2? So total length for element 3 is 300. So it is 300. So 1 minus 1 minus 1 1. So when you multiply this, what you are getting? So it is 800 by 300. So what will get?
2.67, sir.
2.67. Okay, so 34 is equal to. So I will. It is 2.67 into 10 power 5. Right? Hope 10 power 5 is common, right? 1
Yes, sir.
minus 1 minus 1 1. Yeah. So which means I can rewrite this. Okay, 3 4 is equal to. I'm taking only 1 into 10 power 5 as a common term. Remaining putting inside. So 2.65. So 2.7 minus 2.767 minus 2.67 and 2.67. Okay. So the step is over. Next step. Next step, I am going to identify what is my global stiffness matrix. Capital K. Capital K is relating 1, 2, 3, and 4. You know what is the size of my capital K, right? This is my size, right? For easy purpose, in some book they will be drawing some lines, so they will drawing like a tabulation, so for understanding purpose I'm not going to do that because irritatively confuse ஆகும் I'm going to space விட்டு எழுதுறேன், that's it. Okay, so 105 is a common term, I will put it out. So remaining, so let me address this, right? Address one by one. So let me address the first one. So when I address here K12, this is 1 2 and this is 1 2, right? So when I go for element 2 is 2 3 2 3. When I go for element 3, it is 3 4 3 4. This is the connection of the nodes, the how the element is connected with respect to which node. Okay, that's what we are indicating here. So now I will write the same thing here. So I have 1 2 3 4. Similarly here also 1 2 3 4. Okay, let me put accordingly, that's it. So I will use the same color so for better understanding. So this is orange color, I will go for this 3.33, right? So which will be here, so 3.33, so minus 3.33, so minus 3.33, 3.33. This is for the first one. Second one, K23 23, right? So same 3.33. So okay, so it is in 2 3 address. So 2 3 address. So this is 2 3 address. So plus 3.33 minus 3.33 this one. So minus 3.33 and here 3.33. Fourth one it is 3 4. So connecting 3 4 2.67. So plus 2.67 minus 2.67 minus 2.67 and 2.67. Okay, these are my remaining terms. You can put it as 0. So remaining I don't have value here. So 1 3 I don't have, 1 4 I don't have, and 2 4 I don't have. Right. Similarly here. So here I can put it as 0. So these are my terms. Right. So k value is over. Now what I can do, I can identify what is my force matrix. Force matrix. So force matrix is F, which I can write as F1, F2, F3, and F4. Okay. So why we put up to 4? Because our stiffness matrix is 4 cross 4, right? So again here also you have 4, right, which is equal to. So let us identify what are the forces that are available, right? So when you look at the problem, point 1 doesn't have any force. Point 2 you have a force P which is 30 kilonewton, 30 into 10 power 3. Point 3, point 4 no forces, all are 0. So in that case this is 0. This is 30 to 10 power 3. Other things are 0. Okay. Now the next step is I'm going to equate it. So what I will say F is equal to K into U. Right? What is my F? So into U1, U2, U3, U4. So this is my F is equal to K into U. Right? So now what I can do? I can eliminate it. So what are the terms which is 0? So you can able to see that according to the problem, U1 is 0 and U4 is 0. Right? These two terms are zeros. So in that case, this one is 0. In that case, I can eliminate the first row and first column. Right? Similarly, U4 is also 0. Eliminate the fourth row and fourth column. Okay? What are the remaining terms? You can write it that. So you can write that. So I'm getting 30 into 10 power 3, 0 is equal to 1 into 10 power 5. My matrix. So 3.33 plus 3.33. So 6.66 minus 3.33. So minus 3.33. This is how much? So 0, I think 6, right? So you're getting 6. We're getting 6. And here it is U2 and U3. So actual step is I out identify U2, U3. Don't bring it on the other side. So because it is complicated to identify what is the inverse matrix. Instead, you identify what is the equation. What is the equation? Multiply it one by one. So I will multiply it. So I will consider here first term. So 1 into 10 power 5 is common. I'll consider that. Remaining 6.66 into U2. So 6.66 U2 minus 3.33 U3. Minus 3.33 U3 is equal to 30 into 10 power 3. This is equation 1. Right? So next, second, the same 1 into 10 power 5 minus 3.33 into U2 minus 3.33 into U2 plus 6 into U3 is equal to 0. This is my second equation. Now you try to solve these two equations You will get what is the values of U2 and U3. Now we will try to identify what is the value of this U2 and U3. Take a calculator, find out what is this value. So you are getting U2 as 0.062. U2 is equal to 0.062 mm and U3 as 0.0346 mm. 0346 mm. Now we identified the value of this U2 and U3. So the next step what you are going to do is we have to identify what is your elemental stress, right? So what is the elemental stress for this particular elements? So we are having three elements here. So element 1, so which is connecting nodal point 1 and 2, element 2 which is connecting nodal point 2 and 3, and element 3 which is having connecting nodal point 3 and 4. So you will have three stresses, right? So we will be getting three element stresses. We will find one by one. So element stresses. So to identify this element stress, let us consider for element 1 first. So element 1 is equal to, we know the formula. So element 1 is connecting nodal point 1 and nodal point 2. So nodal point 2 will have a displacement U2 and nodal point 1 will have a displacement U1. And the length of this element we will call it as L. So your stress will be Young's modulus into your strain. Strain I can write as U2 minus U1 divided by L. So which is equal to, we know what is the value of Young's modulus. So Young's modulus is 200 into 10 power 3. So 200 into 10 power 3 into U2. So you know U2 is 0.062, which we identified. U1 is 0. So because that side is fixed, divided by your distance. So what is your overall distance? So L is 150. So we are solving everything in Newton and mm. So I am substituting everything in mm. So 150. So you will get what is the values of this stress sigma 1. You will get 200 10 power 3 into 0.062 divided by 150. So I'll get, so 82.6, right? We are getting around 82.6 Newton per mm square. Next, solving for the next element. So element 2, when I consider element 2, it is connecting nodal point 2 and 3. So you know what is the displacement at these two nodes. So U3 which is 0.0346, 0.06, right? 0.6062, right? And your length is also 150. So sigma 2 for this will be equal to Young's modulus 2 into 10 power 5, which is 200 into 10 power 3. Same, both are same. And difference in this two, right? Of course, when I consider U3 and U2, we will substitute accordingly. So U3 is 0.0346 minus 0.062 divided by 150, right? So what is the value you are getting? Minus 36.5 Newton per ounce square. So you will get a negative value here indicating that this is a compressive loading. So you have a compressive stress. So previously a positive value indicates it's a tensile one. So this one is you are having a compressive stress here, right? So next your element 3, let me go for element 3. So for element 3 you have a connection with respect to U4 and U5, and your length is around 300 mm, right? So in that case sigma 3 will be equal to 2 into 10 power 5. U4 is fixed 0 minus U3, sorry, this U3. So U3 is around 0.0342 divided by your length is 300. So let me substitute according to this. So minus 23.06 Newton per mm square. So this is also compressive. So when you are writing, you can write it like this. So something like we are having sigma 1 3, so indicating that this values will be the first one is 82.6, the second one is minus 36.5, third one is minus 23.06. So this is my stress values. So we identify what is this is with respect to this, right? So the next one what they are asking to identify is the support reaction, right? So to identify the support reaction, we know what is the formula with respect to that. So your reaction force will be equal to, so K into U star, so whatever you identify, minus F. So this is the formula. So we know what is the formula for K. This is my K value. So 1 into 10 power 5. So I'll write all the things here. So this is my K value, and your U value. So what we identified. So U1 is 0. We know that. We'll substitute that as 0. So U2 is 0.062. It is 0.062. U3 is identified 0.034. U3 U4 is 0. So this is equal to minus F. What is my force? So my force vectors. My force vectors are 0, 30 into 10 power 3, 0, 30 into 10 power 3, 0 and 0. So the entire solving this, you will get what is your reaction force R. So overall term. So if you do that, you will get what is your reaction force. So how to do this? So you have to multiply it. So you can able to see here this one, right? This one is 4 cross 4 matrix, and this is 4 cross 1 matrix. If I multiply, so I will get 4 cross 1 matrix, right? Minus this 4 cross 1 matrix, you will get what is the value with respect to that, right? So there are few ways. So you can directly multiply it, so one by one, and you can concentrate with respect to that. So the other term is, so you can also use your calculator, right? I think calculator, you can able to use 3 cross 3 matrix, but I don't know about 4 cross 4. So let me check it out. No. So in calculator you don't have 4 cross 4 matrix, so in that case it is difficult. So only thing is you can solve this by using multiplication. So for that, what you can do is you can use things. So you can able to say that whenever I multiply the first row and this column, right, and this row and this column, so you can able to see that. So this part is 0. So since this part is 0, I can see that this you can't able to multiply. So whenever I multiply this with respect to 0, it will become 0. So I can eliminate this. So no need to worry about it. So, and similarly, the last row. So this row will be multiplied with respect to this one, right? So this into this, this into this, this into this, and this into this. So this one also multiplied with this row. So again, this also we can't able to apply, so it can be 0. So remaining terms you can just multiply. So which I will get it as 1 into n power 5 into, so minus 3.33 into 0.062, minus 3.33 into 0.062 plus 0 into 0, so that becomes 0. Next 6.66 into 0.062, yeah, because this becomes 0. So 6.66 into 0.062 minus 3.33 into 0.034. Similarly, this one minus 3.33 into 0.062 plus 6 into 0.034. This becomes 0, so remaining. So minus 2.76 into 0.034. So this plus 0 30 into 10 power 3 0 0. Right, this is my term. So just multiply, you'll get what is the value with respect to that. So this is my value. Along with this, I have to add with this 0 30 into 10 power 3 0 0. So when you do that, I'll get my reaction force R, which is equal to, so minus 2646, and you do that, it will be approximately 0, right? You can able to see here. So, and this will also be approximately 0, remaining minus 9384, right? So whenever you think about it, whenever you have a deflection, you don't have any reaction. So these two, you have U3 and U4 deflections. So that's why your reaction at this points are 0. So the remaining, wherever you are fixing, there only you have a reaction. And if you add this reaction, it will be approximately equal to the value of this 30 into 10 power 3. So you can able to get it approximately. So that is how you can verify it, right? So when you add this, approximately you'll get 30 into 10 power 3, right? So verification can be done by using this values. So wherever you have deflection, your reaction is approximately 0. So 246 is very minimum when compared to 10 power 3. So that's why I put it as 0. So but anyway, there is no deflection here. Okay. So this is how you can verify. So this is your reaction for this particular problem. So this completes our entire problem. So we started with identifying what is our deflection, then our stress, and then we also identified what is the support reaction. Yeah, thank you.